Ready to get started? So good afternoon, everyone. It's a pleasure to introduce Yoav Goldberg. He's a professor in the computer science department at Bar-Ilan University. He's also the research director for the material of the Allen Institute for Artificial Intelligence. Before these positions, he was a postdoctoral research scientist at Google's Yoav. Yoav's research primarily focuses on language understanding, clustering learning, and neural network based methods for non-leaders. His work was received top honors at conferences including Bar-Ilan. Please join me in welcoming you all.
Thanks for the introduction, and nice to be here. Indeed, those were my interests at some point. I still care about them, a bit less now. But yeah, things keep changing, right? With all of those LLMs around. There is some echo. Do you also hear some echo, or only me? Okay. Anyhow, if you don't hear it, it's fine. When I kind of was asked to kind of give this talk, I didn't know really what to talk about, but I had to provide some titles, so I kind of went with a very general, open one. And then I kind of realized maybe I can actually do something even more general. And I changed to this title, which, yeah, so it had like 4 parts, and I tried to go like over all of them and see how much we can cover. I have many different slides, so I'll try to kind of speak, I guess, quickly. But if you have questions, feel free to interrupt and ask. So I'll start by saying that LLMs are really, really amazing, right? They're actually so amazing that like when they were kind of introduced, it was like, yeah, they actually solve many of the things that I was trying to do, right? They kind of really changed how NLP looks like. And then kind of all of those questions came up, like, what does it even mean to do NLP when you have LLMs, right? Like everything kind of is solved to kind of some extent. So like what's interesting to do? And what if I don't care about these kind of very large scale training regimes, which are kind of annoying to kind of tackle? And this talk is basically my, I guess, way to get out of this like crisis and like I try to look at some interesting things that are still interesting to kind of work on as an NLP person, but also like as an NLP person kind of now shifting towards more AI-ish things, because stuff in NLP, many of it is like what used to be NLP is kind of solved in a way, and we have like new frontiers now. Okay, so just like some of my current interests. So LLMs, how do they work? What can and cannot they do well? And how can we use them as building blocks in larger systems? And also, I kind of care about HCI now. So what can we do with them? And with my focus is how do we produce systems that help people interact with information well. And this talk will cover everything but the first one, which is very interesting, but I just like I had to like choose what to include. So that's out. Okay, so let's start by maybe asking what are LLMs? And you can look at the kind of technical definition, right? So they are a sequence model with billions of free parameters meant to predict distribution over the next token given some prefix, estimated over trillion of tokens, further trained with instruction, further trained with RLHF, right? And like preference. So I think that's a definition that we kind of can all agree with. That is like LLMs. Although there are kind of like corner cases that like does it have to be a sequence or a transformer? Are these LLMs? What is like few parameters still counts or not? Like many questions, right? Do we need these things or not? So the boundaries are fuzzy, but I think we all know what an LLM is when we see it. I don't know how or why, but we have some sort of definition, and we'll use that like for now, right? But we can also look at the more popular definition of LLMs. So basically, they're like they're perceived as like silly parrots, which then were fed with all the text in the world, and then they become very super smart, sophisticated, like parrots that can kind of do much more. And in particular, they can get query or question or prompt or like however you want to call it, and it gives you an answer back, right? And this answer is mostly correct some of the time, right? So that's basically a kind of usage-based definition, or like a kind of behavior-based one.
Yeah, you're going to click the turn off the, just click on Zoom to turn that box off.
This box?
Yeah, just
Okay. How do I do that?
the X.
At X?
Yeah.
Okay. Right? Okay. So you can also think about them as like text understanding machines, or as they're like knowledge integrators. That's also kind of a definition that you can look at. And they're also very, very charming, and they're also very, very good liars. I think. Okay, so that would be maybe a perception-based like definition of what these things are. But we can also look at like things based on their abilities, and then they ask what they can do, right? And the first thing, okay, can they understand text, right? And the kind of perception is that yes, they can understand text. And that's kind of the first part of the talk. We study their behavior and try to see, do they actually understand text in their prompts or not? Okay, so they kind of read a lot of text in the world, they understood that maybe, but now we want to kind of provide it some text and see if it understands it or not. And then this has some like various questions here, like what does it mean to understand? How do we measure it? And what, if any, is like really hard to understand? Are there such things? But let's focus first on how do we measure understanding. And now kind of these things come into play. They're very, very charming and they're very, very good liar, and they may trick you into thinking they may understand while they really don't, right? So, and you, I guess all have seen this like picture before, this kind of cartoon. So the impressive abilities kind of depends on the kind of prompter knowing the answer. And if we kind of turn it into question, then the kind of linguistic understanding abilities of LLMs really depends of asking the question is leaking the answer to the thing that you are trying to solve in many cases. So there are really many problems with QA for measuring text understanding, right? So let's see. So I have this text here, and I can ask like a question, and then like some question can be answered without the text, just based on like parametric knowledge, right? So I don't need a text to kind of answer that. Or they can be very similar to the actual text, and it's really hard to make people make those things not similar. So if you wrote a question based on the text, it will have similarities, and it's really, really hard to avoid. And then there are like shortcuts or heuristics, right? So like here, I can ask where did they like protest or when, right? And okay, so where, there is only one location here, so it's easy to kind of answer even if I don't know the text, like just where to the location, like choose one at random, but it might be correct. And when, okay, so there is only one time expression, right? So like you can do, like you can use heuristic. And the kind of issue here is that basically QA measures the understanding of the pair of a text and a kind of question together, and not only of the text, right? So giving the kind of question is leaking an answer. And yeah, the question really provides extra hints. And if the question is like authored by a person, it gives even more hints, and it's really hard to avoid. And in the real world, text and question comes in like different sources, right? You may want to answer the same question over like many texts, and many of which don't, has no answer. So you need to know that there is no answer. And that's how to do. And you need to understand, so how do we measure understanding, right? And one thing you can do is like point to failures, right? So like if you answer the question, I don't know if it's because you understood or you kind of took a shortcut, but if you fail to answer, then you don't understand. Okay, that's at least something we can measure. So, but then like pointing to failures is not that interesting to me. You have to point at interesting failures, but I mean, so there are many examples of like LL failures, and most of them are like trivial, okay? Like you ask it to do something very, very hard, and it failed. And then, okay, so like, why should it do it, right? So like, so what's interesting? So for me, I want to kind of focus on like failures on core abilities. So these things that should be pervasive, that humans do easily, which apply in kind of in like many situations, and may be inherent to how these things were trained, right? So things which are kind of like very, very basic, which can apply in like many different cases. And we found out that like 2 areas of language where these things fail are around things which are implicit and things which are has like possible words in them. And let me kind of show you an example of what this means. So for example, like read the sentence, right? I entered the room, the window was closed. Okay, so what's not specified here that all of you understood or assumed? Well, the window is in the room, right? And this is kind of clear to everyone, but it's not in the context, but it's not really written there. And and this is very, very pervasive. So like if you take like this text and like you focus on like the word expulsion, so it's expulsion of students from somewhere by someone, right? And these are all entities in the text. And if you look at like the kind of Potter assert, so they're at somewhere, right, against someone. So all of those relations, which are like mediated by prepositions, are very, very common across the text. And when people read, we kind of form this connection all the time without even realizing. It's not like something that we do, like it just happens, right? And we understand the text. And we were really intrigued by these relations just kind of before GPT broke out, right? And we were working on like collecting this data, which kind of really did some kind of rich notation of these with like many NP pairs, and we have this very, very nice benchmark. And now we can ask, how well do LLMs do on recovering these, right? So Alon, my student, he kind of created this like benchmark where he turned this data set into question, and he kind of was careful to avoid all of the kind of pitfalls that were there. And it was easy to do with this data. And also he kind of created like several versions of the same like question in like different formats. So either like yes, no, or like NLI kind of stuff, or just like extractive question, right? And models don't do well at all at that, so they kind of fail quite miserably. And also, if you look at the kind of different forms of question, the kind of failure case don't correlate. So they kind of make different mistakes on like different forms. So this shows that they don't really understand this kind of phenomena. Okay, so now let's move to something else. In this work, which Vika and wrote, we were looking at like very, very simple like linguistic phenomena, which humans do very well on, and LLMs seem to struggle. Okay, so here, like for example, Sue was happy, someone was happy, right? Does the kind of if the first is true, is the kind of second true? Sue ate an apple, Sue ate something, right? Like those. So and the answer is always yes. There are also like this dog animal, okay? And then we kind of did the kind of other way around, which is kind of the opposite of that. Let's keep that. And LLMs surprisingly were at or below chance level on answering those, right? Which was like to me like very surprising, but somehow they didn't do it very, very well. And then we kind of even kind of made further, and we put them into a context. So either like John thought that something, and now the answer is always no, because it's kind of based on a thought, right? Or John realized, and it's true because like nothing changed, right? And the kind of first one is basically some form of an like different world, like possible world which you introduce, right? So something is correct in like John's mind, but not in the kind of real world necessarily, right? And the model did change the kind of answer based on the kind of the context, but not in a consistent way and not in a kind of correct way, right? So they kind of so they saw an embedding and they changed their kind of answer, but not in the right way, right? So they are really not be very good at that, and I think it might be related to their objective, which just doesn't really support knowing those things. Okay, and then you can say, okay, but these are very, very not natural examples, so that's something like people say. And then yeah, but also like GSM8K is also not a very typical example, and still you kind of buy that. So yeah, I mean that's not an excuse for me. I think they're like very simple for humans, and you should not fail on them. Then you can say, okay, so can this be solved with like few-shot prompting? I kind of give it some examples, and then of course it could, right? Like it's to be like very easy, but that's basically that, right? Like if you know what you want it to do, then it can do it, right? So And if you, and the question, can an LLM do X, is very different than can I get it to do X, right? Like if I can, I can get it to do many things if I insist, but it doesn't mean that it knows it like out of the box. And then can this be solved by like training or like fine tuning? And of course it can, right? And it was because actually these things were fixed later in like OpenAI models. So now these kind of cases don't happen anymore because they kind of fine tuned it against that. But then you can also ask, can this like vulnerability be like fixed by patching? And yes, it can, but still you want to avoid them like to begin with. Couldn't be avoided, just like be like more careful when writing code. Okay, so I mean, we don't accept these as answers in like security, right? So we shouldn't also with LLMs. If there are like federal cases, they should be fixed, right? And you should point to them. That's part of the kind of agenda. Okay, let's move on to the kind of third work. So now I'll kind of like skip the kind of beginning because there is like 2 stories going on, and I will focus on one of them. So can the models tell when the text does not have the answer, right? So now we ask this question based on the text, and we purposefully use entities that are not common in the world, so it will not be answered based on the kind of parameters, but based on like reasoning over the text. Okay, and we start with like having a very kind of like straightforward sentence, right? The X fought for human rights, and what did the X fight for? And it succeeds. All of the models do it like very, very well. Surprisingly, not 100%, but like still, they're very, very good. And then you say, okay, you kind of ask, did not. And actually, most models are quite good, but like Mistral kind of like fails a bit. But they're kind of pretty good with negation because they were trained against negation, right? But then you can kind of move on, and it is unlikely that, right? So now it's still like no answer. And now they're kind of doing even worse, and like Mistral really, really falls. Might have, all of the models kind of are really bad at not answering this one. If they had, right, like, and also like this, if it is something else. So all of those like possible words and like model semantics make the models really, really bad for some reason. Yeah, so I mean, they're not really good at that. And I think there is like some like problem or like something like very kind of into the kind of way that they were trained that will cause that, right? Because these things are really not very readable from their like pre-training. And maybe they can be trained against that, but it wasn't happened yet. And it's not easy to do. Okay. And these interact, but we'll kind of skip that. Okay. So yeah, that's what I said. And so, okay, can this be solved by fine-tuning? And I mean, that's not really a good question. I mean, like everything can be solved by like fine-tuning. Maybe like better answers. What is else is hard for like models to understand. Can we somehow like formalize the kind of boundaries of easy or hard? And how could we be more careful when training models and so on? And currently, kind of what we're working on in this space, so I can show that a model don't understand this like construction, but then we try to think, what does it mean to actually do understand them in the kind of positive sense? And there I don't have a good answer, and we're like trying to kind of formalize that. What does it mean when someone said like something might have happened, right? Or if something, then something. Like how do you actually like reason about those things? And we're trying to kind of formalize this better. Okay, so some other form of not understanding, which is kind of cute. So look at these like 3 sentences, like a fan at a sporting event, a gentleman with a bow in the woods, a bat flying over a stadium. When you ask DALL-E to kind of give you like images, you get these, right? So both of them have both senses of the word kind of in them. Right? And here it doesn't understand the very kind of core like principle of language that a single role per word in context, right? You don't have both of them, right? And so that was in this paper, we will kind of like discuss this phenomena. And then you can ask, can this be solved by fine tuning? And I'm actually not so sure, or like, what will I even train against? And then you can ask, okay, is it different than the kind of language one or not? And why? Just to kind of give you something to kind of think about. Okay, so do they understand text? Some of it sometimes, right? They're not great at that, but they're improving, and we can patch them to kind of making them better. And it's good, people do patch them and they do get better. But then we can also look not at what they cannot do, but what they can do, and they can do many things very, very well, right? And you can kind of read those. I will not go over them, but they actually, they are quite performant, right? And then we can ask, that's the kind of second part of the talk, the kind of doing stuff. And I'm really interested in using them as components in larger systems. Now, this forum is about like intelligence and not about utility, so I will not like spend too much time on this, but I do want to kind of show some examples of what we are building. Yes.
I mean, you're asking the question can be solved by fine tuning, but the models are getting bigger. So, like, what's your sense that they just get solved with pre-training?
Maybe. I mean, I think that the thing of like the things I've showed about like implicits and like alternative worlds, they were kind of in there also with the kind of very big models. Right? I think you really want to kind of train, like, I mean, I think maybe with like larger pre-training, they will be solved with like fewer fine-tuning examples. But I think the kind of signal is not really there for this sort of task. Maybe it is, it's only kind of a conjecture, right? But I think it's like there is something like fundamental in these that are kind of not specified in text very much. Okay, I mean, again, a feeling, but I think, okay. So like some examples. And so these will be like 3 examples of around finding and making sense of information. Okay, so let's start with the first one, how to organize information. Okay, so here some searches are really easy, like find me documents about bee colonies, or show me all papers from immunoLP. But consuming the results is very, very hard because I'll have many papers and like, what do I do with them, right? I want some high-level overview, and we can use LLMs to kind of organize knowledge in some system, right? And this is by Uri. So that's the kind of like bees example, right? So you can see that it basically gave you, it analyzed topics, and then on the side there, you see that it kind of gave you like subtopics that it found in this like collection, and then you can kind of choose one of them, right? And then you see like subtopics of that, right? And like just by kind of looking into these kind of titles, you learn quite a bit about the subject, right? And then you can kind of like zoom in and kind of see and see the papers, but sometimes you don't even need that. You just want to this kind of like high-level overview of the topic. Sorry, and then yeah, like for each one of them, and if you kind of don't care about bee colonies, you can do the kind of immunoLP one. This is live on the web if you kind of care. So that's basically kind of a summary or like a partial summary, because there are like more topics like down below of the kind of topics in like recent immunoLP, all about LLMs, by the way, like nothing not about LLMs. And then you can kind of like zoom in and see like what's in agents and so on. Okay, so that's kind of useful. It's also endorsed by people which you like may know, right? So like at least one person in this room kind of found it useful. So that's good. Okay, so let's move to the kind of second kind of example, which is a different retrieval criteria. Okay, so as I said, some searches are easy, some are harder. So like, for example, these kind of searches are really hard to do with current technology, right? Now, why is it hard to search for? Because they are searching for more abstract things, right? So I'm not like searching for some animal, but like for animals in general, and any animal would do, right? And current models are trying to kind of make similarity, but not abstractions, right? But we can basically train for that. So that's like this paper, which was then renamed to get it accepted to a conference. But that's basically the kind of same work. And basically what we did there is we thought, okay, that's an inverse problem. It's hard to kind of go from abstract to concrete, but models can go from concrete to abstract. So let's kind of get various description and then tune some like similarity models on them. It actually works like pretty well. So if you take this example of like substance abuse in animals, then you get these kind of results back, which I think they're kind of quite impressive and useful for like many people. And you can see it kind of like quite diverse, and it matches many different things. Of course, this thing is not perfect, and it has like various limitations. I will not go into them, but like that's like a kind of different criteria, and things work pretty well. Okay, and now for the kind of like third utility is going beyond this like single step process. Okay, so how do you search for information or for papers, right? So let's think of like a concrete case. For example, this query. Okay, so I want a data set of unscripted dialogues between two speakers in English where there is some annotation of some property in one of the speakers, right? So you know what you want, you don't really know the kind of vocabulary. What do you do like when you kind of start, right? So like how do you search for these? And basically, I think a kind of strategy, maybe you have different ones, but like broadly, right? You kind of choose a tool. So it's either like Google Scholar, Semantic Scholar, maybe GPT, maybe like Perplexity, something else. Right? Then based on the tool, you write some like initial query, and you tell your kind of query to the tool, either like a kind of questions or like keywords or whatever. Then you look at the results and you assess them. Are they good or not? If they are good, then you are done. If not, you do like follow-up queries, maybe with a different tool, maybe with the kind of same tool. Maybe you kind of learn something from the result and you kind of follow up on that, right? Maybe you can follow citations now. Maybe you say, oh, this author seems promising. Let's see what else they wrote, and so on. Right, so you have this like multi-step process where you try to kind of find what you want, and you kind of learn along the way using different strategies. Okay, which brings us to like Paper Finder, which is a tool we've been developing to Israel, which is basically doing that. So you take this question, you kind of plug it in, and then it's doing like a kind of bunch of stuff, and then it kind of gives you like these results. And kind of, if you kind of look down the results, they're all pretty good, right? They kind of answer this query like very, very nicely, and kind of give you a nice kind of collection of papers that all kind of like together answer your question. Then of course you can feed it into some other like summarizer, but you can also kind of look at them. Okay, and it can handle things like finding a paper by its like description, which is like one thing. It can do things like metadata on stuff. And it can do like very like semantic-y kind of like searches, which are harder to do maybe with other tools. Okay, and sometimes it can answer them in like one single step, but something it actually has to do like several like rounds of like various strategies to kind of find those. There are also things that it cannot do. So for example, things like more than 7B is really hard to search for these days because you don't index on like sizes, so you have to kind of like spell out all of those. Also, like negatives are kind of hard, so you can do them in like post-processing. But if you want like to search for negative, it's really, really hard to search for. The third example is when you have multiple criteria and you want to match all of them. That's still hard. We are trying to kind of do this now, like basically decompose and try, but it's like challenging. And then the kind of last one, you really don't have the kind of vocabulary, and ideally the kind of system will try and like do this like very smart process, but it's not there just yet. But we are working on all of these, and it's basically a kind of complex search process with LLM in the loop, and it does all of the things that I kind of like described before. Like it kind of chooses a kind of strategy, follows, does like citation, following, and so on, right? And it's a very cool and useful system. We are using it internally, and hopefully it will be released as a demo sometime soon-ish, right? Yes.
I mean, it seems like there's a bunch of things like as a human you decided how to do.
Yeah.
Like, to what extent, can the system try to do these things?
So it's a great question because a few slides we'll get to it. I mean, I totally agree. That's a kind of a great question. Okay, and then you can ask, okay, is Paper Finder, right, an LLM agent? And this kind of brings me to the third part of the talk, right? Yeah, like really hard kind of questions, yeah. And that's kind of, so I think the kind of really interesting thing around LLMs these days is how do you use them for planning and executing in like multi-step procedures. And I think they are just not that great at that, but I think that's something that we really should be kind of pushing like towards, and I'm thinking about it a lot, right? And I would say up front, this kind of solution is like scripted like very heavily. We kind of chose like some procedures and we kind of script them in a way that will work well. And there is like LLM in many of the kind of decision points, right? But it's still controlled by primarily by what we kind of like defined, right? And that's on purpose because it works, right? And I also have like students trying to do something kind of more open-ended, and it doesn't quite work as well. So there is kind of a tension between what you can get it to do and like if you want it to do to be more like autonomous. Okay, so that's kind of like this part of the talk. LLM agents, right? So LLM agents are kind of really, really cool these days, right? Or they just like dress cool. They kind of pretend to be kind of cool. And okay, so is Paper Finder an LLM agent, right? So it runs a complex multi-step process in response to the request. It is using multiple tools to do its job. It is using LLMs in several key decisions. So is it an agent? And many people would say yes. I will also say might be, but to me, it's not a very interesting one. Or like it's very useful. It's very interesting because it was not easy to kind of get it to work, and it's doing some interesting things. But agent-wise, it's not very interesting to me. Why? Because if I'm thinking about what is interesting to me about LLM agents is kind of basically lifting LLMs from doing single-step processes to doing multi-step processes. That's how I think of them. I want the LLM to do multi-step or to be used for doing multi-step things in an interesting way, and like in agentic, I guess, with kind of independent of what I tell it to do. Okay, and then you can ask, wait, so are LLMs really single-step like machines? And it's not that simple actually to answer because next token prediction is single-step, but producing a response is not single step, right? It kind of predicts like several tokens to get you what you want, and you actually get some interesting behaviors out of that, right? You kind of get chain of thought, which is basically something that is something that kind of is not possible without this like loop that kind of samples from the model and so on, right? So LLMs are inherently single step because like next token prediction is single step, but we are using them in a kind of multi-step system. Okay, that they were not trained on like specifically. Okay, maybe later some RLHF stuff does kind of target that, but not really like strongly, right? So they were actually trained on single step, and you get very interesting behavior from them being multi-step over that. But also when we talk about LLMs, right? If we like think of them as like a prompt and an answer, then they are single step, right? Because they don't like plan several answers ahead, for example, or at least not trained to do that at all. Okay, again, so they are not really single step, but I will consider them to be single step, like for this. Now you can ask, is chat a multi-step like procedure, right? So what's chat? You basically has some kind of prompt, like system or user, then an answer, then it's kind of fed back, like both of them to kind of the kind of user, and like the kind of like prompt keeps going. Right, so there are multiple steps involved, multiple executions of the LLM with some shared memory kind of being passed around in the prompt, right? But for me, this is not also kind of not real multi-step because the user is controlling the steps, right? And it could be nice to have some like LLM that has some like long-term plan to kind of get the user to some point. I don't think they do that. Basically, the user is kind of really kind of specifying what the next step would be, and it's driving all the process. So it is multi-step, but it's controlled by some other smart agent, which is the human. Now, if you put two LLM agents once against the other, I don't really know what happens, and that's kind of more interesting maybe. But still, I mean, I would consider this to be like a kind of single step because they're like very reactive to the other one. Is tool use multi-step? Well, like in the very kind of primitive sense, yes, because it kind of first uses the tool and then answers it, okay? And I think it's a basis for like doing like more like multi-step part, okay? Now, just kind of to give you some kind of a more schematic view of this. So LLMs and like LLM agents, right? So let's think of the LLM as this thing which is called an LPU, the Linguistic Processing Unit. It's kind of like a CPU, but like for language. And it's composed of like the NTP, which is the next token predictor, which is what we actually train. And then this thing basically gets a buffer, which is like a kind of sequence of tokens. And it like spit out a distribution over tokens. And it's doing that by kind of consulting its very rich read-only linguistic memory. Right, and then there is this kind of process where kind of these things happen in a loop, as I described, and then you kind of get the output, right? So that's what inside the kind of LPU, and that's okay, and that's this component. And then when they are used, basically there is a buffer of instruction and data and maybe tool descriptions specified in text and some structure, maybe like JSON or something like that. It is fed to the LPU, and then what you get back is some buffer that has text and instructions, which are kind of more structured, right? And this is also kind of consulting this kind of like read-only memory, which is inside the LPU, okay? And I like to kind of think about memory architecture. So you can say there is this kind of user-controlled read-only memory in the prompt, okay? That's controlled by like whoever is like supplying the thing. And that's kind of like registers in a CPU, I guess. Like you kind of, like they're very large, but like registers. Then there is this kind of like firmware ROM that you can kind of like consult and read. And then there is this kind of like working memory, which is controlled by the LPU because it kind of generates stuff like further based on the prompt. Okay, so like three kinds of memory in this process, two read-only ones, but like one by the user, one by the system, and then like a working memory, which is more controlled. And there is also, I'll say, I guess, a big question of how do you kind of make sure that the user-controlled read-only memory takes like precedence over the kind of factory memory, and it's an issue now because sometimes these things really kind of consult their kind of firmware and not, or like the kind of like parameters and not the kind of prompt. But people are kind of working on that, right? Okay, so that's an LLM basically, and then with an agent you basically add in some controller, right, which basically feeds into the kind of like buffer, then reads something, interprets it, and feeds back something to the kind of next step, right? And I think that the kind of controller is very, very interesting, and it has like various things, like tools and like maybe memory and like many prompts, and so and like logic and so on. Okay, so it's basically taking this kind of like single-step machine and wraps it in a kind of multi-step process. Okay, so that's my like how I kind of conceptualize things, and you can call them agents or not. Like for me, that's the kind of real story. This kind of controller, and how do you kind of build it to do interesting stuff? Okay, and there is tons of academic work, right, on agents, and it's primarily what I've seen around either coding or like SWE stuff, like software engineering. Or playing games, mostly Minecraft, but some other games as well, Sims maybe. And then there is also like web agents, which is basically perform a task on a website, right? You need to kind of buy a shirt, book a ticket, whatever. Okay, and there is also this kind of whole world of like social agents, which I kind of put aside for now because I don't really do them, and they're less about planning and they're about different things. Okay, so this is about like task agents, let's say. And then how do people go about this kind of multi-step like procedure? So one solution is like O1 as a kind of code, like inference time, right? And what they're basically doing here, they're kind of double down and improve the like within one response, like how much can I do like within one response? We've seen that like chain of thought works very, very well. Now let's do more of that, basically, like train it to kind of do these things. So it's basically RL plus money plus more money. So because you need like money for like training the model, then you need money for inference. And basically it's maybe a like promising direction, but not for me because I don't have money. So I put that like aside as an agenda. I let other people kind of work on that. And it might actually work, right? But just not as my own research agenda. Then there is like scripted multi-step interactions. They work very, very well. I do them. I don't think they are very satisfying from the agentic perspective. Okay, but they are also like very useful and not trivial to do yet. There is this kind of decomposed and follow approach, right? So you kind of get a task, you kind of decompose it with LLM, then you kind of follow each step over the plan. And that's very effective and nice, but if you can decompose upfront, maybe it's not the most interesting agentic task. Again, not trivial to do, but like maybe not the most interesting. Then there is this kind of coalition of agents, like each one doing a part. That works well. I have some thoughts about like what kind of differentiates a single agent from like multi-agent. Maybe it's like a single agent with like multiple roles inside it, right? So there should be some like clear boundaries. I wrote about that, but I will not talk about it now. Okay, but I do have an answer, but like for the kind of sake of time, I'm not going to go into it. And then you have this thing where you kind of try, observe the kind of response, and if you fail, you kind of try again based on the error message. Many things do that. That's kind of very like compile this code. Okay, it fails. Tries again. And kind of it succeeds. And then there is kind of the, I guess, React approach, which is while not done, like do the propose a step and then like perform it, and then while not done, and so on. And I think like that's where the meat is. Like that's the more interesting part. Yes.
So, I mean, I understand like the criticisms of like a simplification, but like there is a sense for O1, if it was the case that it was just doing more inference to find the answer and recognize it, then fine. But the details of
Also doing training, right?
So training to basically do this and then doing search on top of it. Then as he gets closer to where the meat is, it's actually.
I think like, I mean, there definitely could be meat also at O1. I'm saying like O1 is like, O1-like thing is very, very, very promising. But like for me, I guess it's not promising for me because I cannot do that. It's too expensive for me to try. So I leave it to OpenAI or other companies to kind of push the kind of boundaries on that. I'm doing other stuff. I'm not saying it's not good. I'm just trying a different approach maybe, or like I'm kind of pushing for those approaches. And I think it can be like synergistic. And also, I guess like if you want to actually use tools, I don't know that O1 can do that yet, or like how to train with tools. Maybe I do want to train with tools, but I mean, it's a different process. And I think they both can coexist. Like I'm not saying it's bad, I'm just saying like my main objection to O1, something to work on for me is cost. Okay, it's way too expensive and I cannot compete with them. So let them do it, I'll do something else. Okay. So I think that's where the meat is, but also that's where the potential meat is, because currently we are not pushing this very, very far. Okay, I think we could kind of do more interesting stuff in this space. And yeah, I don't have any good solutions. I'm kind of trying to work on that. It's not really working very well, but I will kind of describe where I think the kind of challenges are, or like what's kind of good things to work on. So if you kind of try to think of, okay, what would characterize an interesting task if you want to have like multi-step, like hard procedure for like LLM agent, right? So first it has to be open world or like very large world, right? It has to be like many things. It has to be hard or impossible or challenging at least to kind of decompose upfront, at least for some cases, right? Because if you can kind of like decompose, maybe it's too easy. You need to have a large action space that actually kind of requires certs, so you don't want it to be very reactive. You need to have open and large objective space so that you can not just like trying to overfit this like specific thing. It has to have some semantically vague objective maybe, so it's not real, so it's not really kind of hard to kind of brute force. You want to have a weak reward signal such that you don't get a kind of clear reward at each step. So like for example, if you try to do something and it immediately fails and you know why it failed, it's much easier to do than if you did something and you don't know, like something happened but you're not sure what. And then if you have a non-binary objective, so not like it failed, but like a collect all x or like find the best x, now you have to kind of work much harder to see if you're done or not, and it's kind of much more interesting. Okay, and for me, or like, and some other requirement is it has to be focused enough to be benchmarkable, because if you cannot measure it, then it's really hard to kind of see how well you're doing. And for me, it should be a useful and non-toy task, and it should meaningfully involve language. That's my own preference, but I think it's important. Okay, and you can look at your favorite agentic task and see how does it fare on these. And I would argue that like coding, games, and like web agents are kind of in the easy kind of part of these for many cases. And they're easy for a good reason, because you want to actually progress. You kind of don't want to get stuck. It's only me that I'm trying to kind of do things that cannot really happen. So I mean, there are good reasons to work on these kind of easier setups, because they are still not solved, and there are like many issues there. But for me, it's not very interesting to work on, and I kind of try to kind of find tasks which are more like like more challenging on this front. So, and the kind of big question in multi-step for me are how to keep track of intermediate goals, right? How to keep track of like intermediate knowledge, keep track of the state, keep track of the plan, right? And like knowing where to stop. And you can kind of see that like all of those is like keeping track of something, right? Which is kind of hard to do, especially if you don't want to kind of specify upfront how to do it, right? You want the kind of agent to do it maybe on its own. So what's the kind of mechanism there is a kind of very big question. Now, people usually answer it, okay, you do those things in the prompt or in the vector DB or in some memory unit. And for me, these are really not answers. It's like if I ask you, how do I write an LLM agent, and you tell me use Python and like VS Code and like some LLM API. I mean, of course you use those things, right? But how do you use them? Like that's a kind of really big question. How do you store something in the prompt or in the kind of vector DB in a meaningful way? Right? And there is also this kind of meta question is how do I kind of model the learning process without gradients? And I'll get to this later, but currently most models really kind of sidestep this issue. And again, for like good reasons, because they just kind of have to work. Okay, now I think like my challenge for all of these is kind of what I sort of said before. It's a search or information seeking agent. And I think this ticks all of the kind of boxes. So basically the setup is the user asks a question that kind of requires to look up in some large collection or the internet, right? And then the LLM tries to answer it with like whatever tools that it can. Either like one tool like Google or like everything that it can. This I think is a very challenging setup. So it's hard, it's useful, it's important. It has like many interesting questions. And for now, it's inherently very linguistic. Of course, we can also extend it to do like a code search, video search, all of those things. But yeah, I think it's kind of like very promising. And also searching is about learning, which is kind of cool. Okay, so like you search, you kind of learn something new, and you kind of progress. So I think if you kind of look at those criteria, pretty much all of them are met there, especially if you say, I don't want to have like one kind of good document, I want to find like kind of a good set that kind of covers this, right? And some search questions are easy, some of them are really much harder to do. And it is benchmarkable and useful and linguistically and so on. So basically, and all of those things apply there, and they're hard to do. I know because I tried and I don't get it to work, but I think it's kind of like very promising. So basically, if you want a challenging and interesting case for like this, try seeking for information. I hope to release a kind of useful benchmark soon, but if not, I'll be happy to see your benchmarks like for this. Okay. And if you want really even more challenging, then let it do research, right? Like teach me about something very complex and let it kind of do its work. This is really like, I guess, like few years ahead, but also very, very interesting. Okay, and now for the kind of last part of the talk, dreaming with LLMs. That's kind of wild. That's kind of, I've been thinking about this idea for the past, I guess, 2 weeks or so, which is, so it's really not really well baked, but I think it's very promising, and I will kind of appreciate, like feedback on it. And yeah, I think like there is really either a potential for something very, very big here, or I'm just rambling. So it's like it could be either way, but I like think of it as like very interesting now, and that's why it's kind of like dreaming. Okay, and you can kind of begin with this question: how did you imagine machines that learn before you knew ML? I think it was kind of different from ML if you kind of imagine it. So let's kind of have this question in the kind of back of our minds and see where we go. And now we can kind of think of our kind of paper seeking agent, right? So I ask it which papers from NLP venues, cite paper from CHI, and it say, what are NLP venues, right? I don't know them. And then I kind of give it an answer, and then it says, oh, great, these are the papers, right? So this works pretty well. Now, a week later, I ask it papers in NLP venues about UX aspects of agents, and it says, oh, NLP venues, what are they? Can you give me an answer, right? Because it doesn't have any persistency in like long-term memory like that. And like, it's really disappointing that we cannot do learning even in this very, very, very basic sense, right? And you can say, okay, just store it in memory. And yes, of course, but that's not that easy. And that's where I think most of the kind of meat is, like, how do you store things into memory? And I'll kind of describe it more. So like one thing about current ML systems, I think all of them basically, it's that they are machines that learned and not learning, right? You train it and then you do inference, right? It's not really training as you go. I want system that actually learns as it progresses, right? And I'm saying system and not model because I think there is a difference, right? And you can say, okay, there is online learning, there is like lifelong learning, but really they are not that great. So like current online systems, they adapt, but they also forget, right? They don't kind of keep. And what you call lifelong, so there are like a bunch of works on that, and they try to really kind of adapt and remember, but they're not online. They're kind of training and retraining and retraining, like for new tasks. Okay, and the other distinction is basically machine learning models learn to and not learn that, right? So they learn to classify images. They learn to give you good answers, right? But they don't say learn that a dog has 4 legs, for example, or like things like that. So, and they may kind of learn some of those things implicitly in their parameters, but it's not a declarative knowledge. You cannot teach them declaratively, and you cannot poke at it declaratively. You don't really know what they learned, right? And just to, basically, our learning is very procedural, how to do a kind of procedure, but not kind of declarative. And then you can say, okay, what does it mean to know that something? Yes.
Can you go back one slide? How do you know that? Like, what's the evidence for this?
I mean, so first, I mean, as I said, they may learn some internal representation about things, and they have their own word model, but I cannot poke at that. And I cannot teach them in this way. Like I cannot tell like an image classifier know that dogs have 4 legs and now have them improve, for example, right? It's not how they work, right?
But if a VLM reads a bunch of times that dogs have 4 legs, would you consider
Maybe,
that?
maybe. I mean, it's really so. Maybe kind of this next kind of slide will kind of answer, and if not, we can go back. So what does it actually mean to kind of learn that? So for example, here, I ask what does allegedly means, and it gives me a very nice response, right? So it clearly knows what is allegedly. But then I ask it this thing, if the kind of first sentence is true, does it mean that the second one is also true? Okay, the answer is no, and it says yes, right? And we can also kind of rephrase that, and it will also say yes, right? So, I mean, I think, okay, so it knows it, but not how to apply it. So it really doesn't really know it in that sense, right? So I think like being able to know that, first you need to retrieve this fact when prompted, but you also need to use that when it's appropriate, right? But you also need to know when to retrieve that fact when it's needed. And that's the hard part, right? Yes.
You mentioned to O1. If we think about O1 for this, one thing O1 might be able to do is think about what is the meaning of allegedly. It prompts itself, then it retrieves the definition, and then it kind of uses the expanded definition of the word to solve the problem. It's
Yeah.
kind of querying itself in that way.
Yeah. So
Would that count if it's like if it's like doing it out loud in the context or the
yeah, I mean, like, chain of thought does help in that, right? And also like O1 kind of stuff, right? So, and some kind of, I had this kind of realization like a few days ago that basically chain of thought, you can think of it as like a sketch pad. You can also think about it as like a memory search.
Yeah.
Right. So like chain of thought helps it kind of search its own memory and like bring things to the surface. Right. So that's a kind of good definition. Okay. But also like O1, it's really hard to kind of teach it new facts. Right. So that's kind of where things are missing. Right. It's kind of relies only on its parametric knowledge. Now you can ask, okay, if I kind of got to a new conclusion based on what I know, is it new? Is it new stuff or not? And that's a big philosophical question. I will not go into it, but yes. Okay, so let me kind of redefine what learning means for me, or like what some form of learning means. I want to change memory based on observation in a way that will affect future behaviors as many as possible in a positive way, hopefully. Okay, so, and when I say observation, basically it could be either something that I was taught by others, I was told something declaratively, or I can see something about the world. It could be like a lot of actions. It could be like someone that I did like internally, and I want to learn from that. So kind of so I don't have to do it again. I kind of I had this monologue. Now let's kind of return. And it could be like what I kind of already remember that I want to kind of reorganize. Right. So I think like for me that's a very big, interesting question. Like how do we learn this way? And this requires basically kind of that the current experience affects like future actions. You need to commit to memory when needed. You need to retrieve from memory at the right time, hard. You need to identify like what's useful in like observation. You need to hopefully make abstractions. So I don't want to learn only like the fact, but something like maybe more like general. And I need to maybe be able to identify knowledge gaps and actively seek to close them. Also kind of hard-ish, but like I think very interesting from a kind of intelligence perspective, I guess. And I also want to have like language-based learning in the sense that when people learn, it's mediated through language, right? So we either learn from something that someone said to us, and we kind of need to kind of take this into account. We learn by thinking about things in language, right? So like a lot of our thinking goes through like internal thoughts, but in language. We learn by abstraction that we form in language. And the question is like, can we make learning systems that use language like explicitly? Like for me, that's the kind of big question, and I think we sort of can, right? So basically, the dream is like explicit, declarative, online, lifelong learning system. Okay, let's break that apart. So learning, as I said before, update memory to improve behavior. That's my kind of definition of that. Declarative, I want to learn that and not only learn to. Okay, and of course, and you can also like learn that in a kind of very, I guess, like superficial way. Okay, I say the knowledge, the LLM knows that the token distribution over the next kind of calculation is, okay, so it knows that, but it's not what I wanted to learn, right? I want to actually kind of give it facts, and they should be explicit. So they should be like, it should manipulate like statements which are explicit. This is also kind of good from the safety, I guess, if you care about safety and like X risk and that's kind of good because you can see what it's doing. I wanted to kind of be learning, not learn, so like keep improving. And like lifelong means it should have like very long horizon, very like very large memories and like cross task stuff, which means I cannot do everything in the prompt realistically, okay? Because maybe the kind of prompt would be at some point too small. And I want it to be systems and not models because these things require systems, I think. It's not like a one model. It's kind of a larger thing that we kind of care about. And you can call those e-dolls because they're kind of not a great name, but not a terrible name either. Maybe we call them learning agents instead. Okay, so I'll go with learning agent, but I'm still thinking about kind of the kind of name for this. And the thing is that like I want some learning mechanism that is not working by only altering parameters, right? But by managing memory with observation. And I'm not saying it should replace what we did before, because that's very useful. It was like supplement, like it's a new form of learning that we didn't explore yet that much, and maybe we can now, right? And people in like old style AI did do this kind of declarative learning things, but not with real language because it was too hard. And now we can do it with real language, which is kind of much better than like, it's like predicates that they used before. Is there a question up to this point? Yes.
Yes. Very naive setup would just be that you put everything epsilon back, data database, and we retrieve them. Like, yeah, could you comment on like what is the drawback on this? What do you mean by that?
Okay, so basically what you said, store everything into some database and then retrieve it when needed, right? With RAG. So I agree, but I think retrieve it when needed is really not that easy. And store everything is also not that easy. I mean, okay, you can store everything, but how to store something in a way which is retrievable later at the right time, and how do you organize things such that they are this way? That's not trivial to do in my view, and that's where most of the meat is. I will touch about this also later, and we can kind of like continue in a few slides if you're not satisfied. Okay, over there, goodbye.
What you're missing is like thing that's both visual and voice, right? Like you don't really have that. It's like the thing that you can write to is kind of like ongoing problem with a chain of custody. It seems like we're kind of even without a database, we need something that's like large.
Yeah, okay, so you said I need to have some kind of memory, which is kind of large and gradual, and I think we have this here in like this mem1, mem-n thing in the controller, right? So we can have large memories in the kind of controllers, and people use that. What we don't know is how to use them effectively, and I think that's where most of the thing is. I skipped a few slides back, now I have to kind of skip them again, but so I'll take some other question. Yeah, over there.
So do you not want to update weights?
I'm fine with doing that. I think we don't know how to do it like in an online fashion yet. Maybe we can do like periodic updating of weights, or maybe like in a kind of like once every kind of sometime you can learn. That's open, right? I mean, I'm not against that, and I'm not saying how you should go about that. I just want the ability to have, to have this thing, right? And here I said like not update weights, but like I think like it's useful to kind of think about that in that sense. If this involves like weights as part of it, fine. Personally, I will kind of start other ways, but I mean it's possible.
So is it more like selective forgetting and then aggregating memories together?
That could be an approach. I mean, I can think of like many ways to kind of go about that. They're all challenging in different ways. I'm kind of proposing, like kind of basically like research agenda and not a solution. But I do have some things in mind. And yes, like with parameters, without parameters, there are like many ways. And it's good that you can have that kind of it intrigues you, and we can kind of maybe discuss later. But yeah, that's basically the agenda. Yes.
And it's the distinction between models and systems is because you don't want like an architecture that you just optimize with gradient descent that you solve every problem.
I mean, you can, but I think that thinking in terms of models is a bit restricting. I think you can kind of like do more when you think of maybe like more modular systems where the LLM is a component of that and not like an end-to-end thing. But like if you can solve it with a model, go for it. Like I'm not against the kind of concept. I think of it as like a system which is kind of more involved and like has more parts. And if you think about like how people like conceptualize human like behavioral thinking, okay, so there is the brain, it learns, but it also have like subcomponents and like different functions. And I think the kind of system view is largely maybe ignored in many ways and is important, or like not ignored, underutilized. Okay, yes.
So I guess like one thing which like LLMs can give us is that a lot of declarative knowledge, I think, is actually much softer than we would like it to be, and kind of language can capture that. And I think, like in your allegedly example, right? It's like no one really knows the definition of allegedly, but people know that it has some weird relationship between the world and what the person who's saying it wants to convey, right? And like that's kind of hard to store as like a declarative fact somewhere outside of like the language system. And like, of course, there's like facts that are separate from the language system, but I think that the reason LLMs have given us this feed, or like one of the reasons is like that. And so how would you navigate the fact that a lot of knowledge kind of needs this stuff?
Yeah. Great question. I will repeat it. It's saying that like language knowledge requires some soft like reasoning over it, which LLM sort of gives us in some way. And I think that's precisely what was kind of missing, right? Like we couldn't really manipulate language in this like way before, and now there is a chance because this kind of soft reasoning is captured relatively well by kind of LLMs, and we can build on that. I'm not sure how exactly, but I think that's kind of part of the solution. And now I think we kind of go on a bit, and then we can kind of take questions at the end, because also some of them kind of related to what I'm going to say. So let's have it at the end. Okay, so now we can ask, aren't current agents already kind of learning agents? So for example, if you look of this paper, cognitive architecture for language agents, very recommended. Do read if you kind of want. Then they kind of describe this kind of like mechanism, and it has, you know, the kind of LLM and like retrieval and learning and memory and reasoning. So it's all there, right? So like, I mean, I guess the kind of story is there in a sense, but current like agent works are not really pushing it very, very far. So there is some POC that like some form of learning is possible with some very basic long-term memory via RAG. And like we can learn how to retrieve skills or facts, can store and retrieve. So there is like very nice POCs. There is also kind of POCs that you can make abstraction and you can reflect, right? So like words, so like works like Voyager, Clean, Ghost in the Minecraft, Reflection, like various like words like that, show all of the kind of building blocks. But it's really all at the kind of like surface, like starting the surface, like very POC-like. And there is a lot more to be done if you want to tackle the kind of large question. And again, people avoid for like various reasons. It's hard, it's not really benchmarkable yet, and so on. But I think it's like fascinating. But like basically, I think multi-step tool using processes around LLMs can unlock a really new kind of machine learning, which is kind of like memory based. But current works focus their efforts still on the kind of procedures, right, and not on the learning. And there are good reasons for that, like it's easier maybe, and it also doesn't really work very well. And now I kind of found this like quote from a book which was famous at some point, Human Problem Solving, by like Newell and Simon, who are like really AI pioneers who switched from AI to like psychology. And what they say here, right, if performance, say procedure, is not well understood, it is somewhat premature to study learning, right? And if it is our judgment that in the present state of the art, studying performance must be given like precedence. So they said, okay, we will do performance before learning because that's what we can do now. I think now it's actually a good time to also study learning, even though performance is not fully solved. I think you can do like both things, right? And I think now it's a good time to start. And basically, this kind of explicit declarative online learning systems, it's basically a new research program, if you say. So it's not like one work, it's like maybe many works that requires new theories, new architectures, and new methods, and like shifting focus, I think, from models to systems, although you may also do it in the kind of model-centric way. And I think it's kind of shifting focus from optimization and loss functions into long-term explicit management of memory. And there are like many, many big questions there. Now you can ask, oh, just do RAG, right? And RAG, that's only the same as just use Python, right? Because, you know, like RAG is basically enrich the prompt with retrieved information. And of course, but what should I retrieve, right? And how did the index was structured, and how did the information got into the index to begin with, right? So you can store everything, right? But then how do you retrieve the kind of writing at the right time? So you need to basically store something in a form which is kind of retrievable later, and you have to reorganize it so that it will be useful, like based on new information. So there are like many kind of core questions there. Maybe it's more in like psychology issues and not like learning issues, but like it's really a new kind of learning maybe with like different expertise, right? But it's a new thing, I think. And like some quick, so like some of the kind of key questions you can ask now is what, when, and how to store things, right? How to retrieve when needed. Maybe you want to delete memories or update it, right? So like things change. Okay, so what new fact should update memory? What should not, right? Like how do you update it, right? How do you know what to update? These are all kind of hard questions. How to organize and reorganize your memory such that things are retrievable. How do you combine declarative, procedural, and like episodic stuff? If you don't know these terms, read that kind of cognitive paper or ask ChatGPT. It will answer them like pretty well for you. You maybe want to reweight memories periodically, right? So that will be a kind of more learning-based approach, like downweight, upweight. You want to separate prior knowledge from like new knowledge. You want to track levels of like reliability. So I heard this thing, but maybe not in a kind of reliable sense. Maybe it's only like very like task specific and so on. You want to handle things which kind of like conflict, right? So that's just like partial kind of list. There are many, many big questions here. Yeah. And then you can ask, okay, maybe just increase context length so that it can include all the memories in the world and then train the models effectively to use these memories, right? And I mean, yes, that's an approach that people with a lot of money can take. And basically, it says we only have like memory which is episodic that we did before, and it's managed by the LLM, right? So basically, I say all of those like big questions, just like train a model, it will be fine, okay? And that's a possible approach. I'm sure people will try it. I'm not sure, like I will try other approaches, which are also possible, and I think they are kind of synergistic, right? So I'm not saying don't do that. I'm saying I'm doing something else. But I also want to kind of point you to this paper that we kind of published recently that shows that like long context lengths are not really good when you try to do complex reasoning over them. It may improve, but really it's not perfect just yet. So I think it's time. Let's do it. Lifelong learning by storing, manipulating, retrieving natural language text. And I think with LLMs or LPUs, it's like building blocks. This might just be possible. And to conclude, we have seen like 4 parts to this. First, studying LLM behaviors and language understanding of things in the prompt, not in the kind of world, is far from perfect. And I think implicits and like hypotheticals are important and hard, and we should focus on them a bit more. Doing stuff with LLMs, I think we can do a lot of stuff. I personally care about organizing and finding information. I think agentic workflows that are interesting if they kind of attempt to lift LLMs from single to kind of multi-step. And I think if you want to find a really challenging case, learning, research, search is kind of the kind of thing to go. And then there's this dream of memories and LLMs and tools that can enable new kinds of learning machines. I think that kind of these learning agents or idols are the new like frontier. And really, let's do this. I'll just kind of give you one kind of last thing to kind of think about. This thing can also do meta learning in the sense that if I have the agent use tools, right, and if I supply tools that allow writing to memory directly, right, and reading, then it can store instructions for its like future use. And if I give it machines tools to look at its past memories, or if I give it tools to look at its prompt and change them, right, or add to them, right, you can have like many possibilities. And again, it will be hard to make it work and so on, but there are many kind of interesting things to be done in this space. I'll end by that and I'll take questions. Thank you. Yes.
Great talk. I was wondering for sort of the meta system that you're proposing, is the English language or like natural language the right sort of glue logic, the way people are setting up agentic workflows right now, or is there another like programming language or structure that would be for that?
Okay, so you said maybe the kind of right thing to store memories in is not natural language, but some other kind of more formal language. Mm,
For the stuff that you're using to sort of set up that layer of like, that operating system, should that be written in prompts?
Yeah, so should the kind of OS be in prompts or some other thing? It's a big question. I don't know, right? So like one thing that's nice about prompts that they can be interpreted by the kind of LPUs or the LLMs. More formal things depends on the formal thing, and you have to kind of teach it like somehow. But it's really, I think it's open. Like I think there should be like some prompt each components and some others. I don't know. It's really open for me. Want to ask? Yes.
Learning room for
So you're saying, can we kind of get insights on how to like manage memory? I think it's a big question, and I think looking at like psychology or like behavioral studies might work. I mean, it's not like a lot of work is really on the low level stuff. That's not that kind of interesting, but there are also kind of work, like how to take notes, how to organize them, how to make abstractions. So maybe like around that, maybe around education, maybe you can, so like storing a memory in the LLM could be thought of maybe, taking notes for yourself, right? So, and I know that like when I take notes for myself, usually they're kind of just lost later because I never like retrieve them when I need to. But I think there are like many strategies around that and how to organize things. So maybe that's a place. Right, so I mean, there are places. I'm just not sure what they are yet. But yes.
What about on the maybe on the flip side, using like these, O1 style, super expensive models to find the optimal ways of storing these kinds of memories and doing like long-term planning that you can adapt as like rules, like because I think even when you're thinking, I mean, just as a we've had, models that can beat like B trees at like storage that B trees are supposed to be the right way for like such a long time, right? So it's even in cases where you have like strict storage required, doesn't seem like you're better off being.
Okay, so you're saying let's do some kind of meta learning thing and like train an O1 style model to manage the memory for us in a kind of good way. And yes, I'm happy with like that's an approach. Again, like not against it.
I guess I'm saying, like, can we develop an understanding from looking at how the best models learn to?
Oh, for sure. I mean, I think like it goes both ways. So like first, I think we can kind of look at like what models do and kind of learn how to do the systems better. But also, I think once we do these kind of like memory-based systems, we'll also see where LLMs fail us and where they need to be improved, and we can kind of train that, right? So it's very synergistic, like both ways. I think we can. Yeah. Yes.
Thank you so much for this lecture. So going back, you mentioned previously application within sandbox style video games like Minecraft. Have you also looked into LLM models in like the context of like the RPG genre, using LLM to develop AI or NPC or mob dialogue?
Yeah, so you're asking if I looked at like agents for like games on like NPCs or like games. I didn't. I'm sure there are works. I'm not familiar. So sorry.
Oh, no worries. Thank you.
Yes.
Like how close? So you know, you're getting this from the language perspective, but like it seems like long-term memory is also information is not like how important is it to you that the memory question is solved by language?
Okay, so you're saying long-term memory can be like beyond language, like animals learn long-term behavior without language and so on. And I agree, it's fascinating to do. I think, fortunately, like now we have LLMs and they do language, so I can focus on that. I don't think we have the mechanism to do long-term learning declaratively without, right? So that's why I focus on that. I think it's also like fascinating to kind of do like long-term like trajectories, but I don't have the tools, right? So I can focus on language because that's what we know how to do now, fortunately. So like we have this like a new great toy, or like not toy, like a device, right? Let's use this device to kind of do things, and I don't think it can do non-verbal memories yet. Yes.
Can you talk a bit more about the declarative part? I'm trying to understand that. So you're saying that it learns how to describe something or how to use something, but not what that thing is. Is that correct?
So you're asking like, what's the difference between like learn to and learn that kind of thing? Yeah. So yeah, I think like when we kind of talk and I tell you something like NLP venues are XYZ, like now you know that, right? Like you know that thing. On the other hand, I think LLMs know how to produce good lists of them, but they don't know maybe what they are, or at least you can't really teach it to them this way, in a way that will integrate their knowledge. Right? And I think, again, you can describe every system as also learning that, or you can say, oh, behind the scenes, it did learn those features, which means that. But like for me, I think this kind of thing should be explicit. And I think like when we talk to people, right, tons of learning is declarative, right? You kind of read a book and then you learn facts, right, from the book, from declarations, right? And you think about them in your head as declarations, right? And you arrange them in different forms as like these kind of linguistic units, and not as something which is kind of very like transparent to you. Again, that's not all of learning. That's part of it, right? And I think this part is really kind of ignored in the current systems, and it would be nice to approach.
You're saying that they don't learn as declarations? So what do they learn them as?
A model of like prediction. I don't know. Like I don't know what they do. I mean, I really kind of try to kind of interpret them quite a lot, but I don't know what they actually learn. So there might be some word model behind that, but I cannot really query from that. I mean, it's really, yeah, I don't know what they do, like what they do, but and definitely when I teach them stuff, I don't do it declaratively. I do it by examples to do a task, right? So you can say, okay, maybe the kind of thing like this image is of a cat is a declaration. I mean, yeah, you can do it this way. I think it's not really the kind of models learn to identify cats and not what a cat is. And it may kind of learn a sense of what a cat is, right? But it learns it from its own, like seeing many examples. So there is some, I think it's a very different nature of learning than learning by definitions or by declarations. But I mean, I'm not kind of really hung on it. If you want to say, no, they are doing that, fine. I think there is, but I think there is some kind of difference that you can agree that is happening.
Yeah, I have no answer.
Okay.
Let's think I'll speak one more time.